In this video I want to try to tackle the problem of how people get confused in terms of strategies that they might know about how to simplify algebraic expressions, especially the fraction type, and when they're actually solving algebraic equations. So let's take a look at these two things. First of all, an expression has no equal sign, and so, put this in red, no equal sign. We know that we're not trying to solve for something, all we can do is simplify. So they are really looking here, to see if we can just make this look a little bit prettier. Maybe instead of two fractions we can get it into one. So what we're aiming to use here would be something that would give us a common denominator. Okay. For an equation, you can see that there actually is an equal sign. So we have an equal sign, and that means we can solve this. We can actually say that x equals something. So we have a difference here between just simplifying and solving. And here we might still be using common denominators if we need to. But in this case, we just need to make sure we're keeping that in mind. We're only trying to simplify with an expression, and we're actually going to be able to solve with an equation. Now, so for simplifying expressions, we need to make sure that we're careful not to change either of those fractions. Because, for instance, if I had 2 plus 4, and I decided to make that, 3 randomly, plus 4, those are no longer the same thing. And it's kind of the same idea with the equation. If I have 2 on one side of the equal sign and 2 on the other side of the equation, I can't just change this one to 3. It's no longer equal. It's not going to work out. I need to make sure I change the other one to 3 as well. So those are the two kind of principles that are going to guide us for how we do these, is making sure we don't change the problem. So in this first example with the expressions, I'm going to think to myself, well, I see that I'm adding fractions, and to add fractions I know I have to have a common denominator. So I'm going to ask myself, okay, with a 4 and a 5, is there anything that they're both factors of, something that we can times both of them into easily? And in this case, 20 is probably the easiest thing. So I will ask myself, how do I change a 4 into a 20? What do I need to times by? And here, I need to times by 5 on the bottom, and that means I also need to times by 5 on the top. And the reason I'm doing this, if you're having any little fits about, oh, why don't you just cross-multiply or something? Well, cross-multiplying can get you into heaps of trouble as the math starts to get harder, so drop that idea if you still believe in it. I want you to think really carefully here. If I times the bottom by 5, and I times the top by 5, it's kind of the same thing as timesing it by the fraction, 5 over 5. Well, let's break that down for a minute. What's 5 divided by 5? You're right, it is equal to 1. So if I times x by 4 by 1, have I changed anything? No. And that's why we times both the top and the bottom, something that you might have not shown or forgotten that you were even doing years ago as you were using cross-multiply, but we need to remember that's actually what we're doing. We're timesing the top and the bottom by 5, so that we don't change that fraction. 5x over 20 is the exact same thing as x over 4. So here I'll go ahead and do that, times the top by 5, so I get 5x over 20. And again, because these are equivalent fractions, I haven't actually changed the value of it, I've just changed the way it looks. Okay, I still have my plus sign between. And my next side of the expression here, I need to think, what do I need to times 5 by to get to 20? And again, this time it's going to be 4. And I'm going to times the bottom by 4, which means I'm also going to times the top by 4, because timesing by the fraction 4 over 4 is the same thing as timesing by 1, I don't change it. Put brackets around that big fraction bar to make sure that you actually expand it all the way through, because every single thing on top of that fraction needs to be times by 4. If we forget the brackets, we might forget to times everything. So this means I'm going to get 4 times 3x gives me 12x, and 4 times 1 gives me 4, so plus 4, over 20. And I see there's a plus sign there, so I don't need to worry about expanding that through. I can drop off the bracket. Now that these have common denominators, I can write them together and just go ahead and add the tops. So, looking to add like terms, I have 5x plus 12x. That's going to give me 17x. And then plus 4 has nothing else to add to itself. So that's my final answer. And again, I'm going through this to be really careful because as maths goes on, you get into harder situations where you need to be aware of this fact that you're not changing the fraction because you're timesing the top and the bottom by the same number. Now in the other example here, we're going to look at an equation. And I could still use common denominators here to try and solve this problem, but for me, I just think of it maybe another way to go about doing this is making it more simple by getting rid of the fractions altogether. So I go over this again in the, how to solve equations with fractions video in more detail, but let's look at this problem again. The same idea that I had over here, that I wanted to make sure I didn't change the expression by timesing by 4 over 4, which is the same thing as 1. That's the same principle here. I need to make sure I don't change this equation. Remember, with equations, they're balanced, so what I do to one side, I have to make sure I do to the other side. So my trick here for solving an equation is going to be to times by the denominators. So if I see a 3 on the bottom, I'm going to times by 3 to every single thing on both sides of the equation. Put my brackets around that big fraction bar so I don't forget. And timesing by 3 is the same thing as dividing by 3. Now in this case, I do get to cancel stuff off, and that's okay. Keeping in mind that I'm doing a legal move here because I'm timesing every single thing by 3. So if you think back to that scale analogy, keeping things balanced on an equal sign, if I times this side by 3 and I times the other side by 3, they're both 3 times bigger, but they're still equal to each other. And to make that happen, if you've got more than one thing on one side of the equation, you need to make sure you times both things by 3. Okay, so looking at the next one, I see a 2 on the bottom. If I times everything by 2 now, I haven't changed the equation, it's still balanced, but now timesing by 2 and dividing by 2, I can cancel the 2 off the bottom on that term. My last step here, I see a 4 on that side of the equation on the bottom, so I'm going to times by 4 and go back and times every single thing by 4 again. So everything's been times by 4, timesing by 4, dividing by 4, they simplify each other. Now I'm going to come back and take a look. For that first term, I've got times by 4, times by 2, that's a total of times by 8. So timesing by 8 to the 2x there gets me to a total of 16x. Next case here, I see that I have a 4 and a 3 left. That's 12, so 4 times 3 is 12. So 12 times 4, making sure that I expand it to every single term inside those brackets. 12 times 4 gets me to 48x, and 12 times 1 is 12. I'm going to leave those brackets and watch that minus sign. On the other side of the equation, I now have a total of 6 left, 3 times 2, because the 4 is cancelled. So 3 times 2 is 6, and 6 times 7 is 42x. My last step here, again, you could do this in one step, but if you aren't catching it yet, make sure you write it out in 2 steps so you don't forget. That negative needs to be taken through because I have to subtract by every single thing on top of that fraction. Subtract by the 48 and subtract by the 12. So if I expand that negative through, I get 16x minus 48x minus 12 because I have to take that negative through, and that is equal to 42x. Next step for me will be combining like terms. I've got a positive 16x and a negative 48x. Those are going to combine together to give me a negative 32x minus 12 is equal to 42x. Taking the x's to the same side, I'm just going to go ahead and take that negative 32x to the other side by doing the same thing to both sides of the equation. Plus 32x on one side, plus 32x on the other side. Those cancel. I'm left with negative 12 is equal to 74x. And in my last step, 74x is timesing, so the opposite of timesing would be to divide. So I get negative 12 over 74 is equal to x. And we can simplify that. Both of those are divisible by 2. So I get negative 6 over 37 is equal to x as my final answer. So again, with expressions, you have an equal sign, and you need to make sure you're timesing the top and the bottom so that you're timesing by a 1 to not change anything. and you're just looking to get a common denominator and add the fractions together. When you're looking to solve an equation, you can think about undoing the fractions in a way, getting rid of them, by timesing every single term by the bottom. If you're careful with that and draw out your answers as you go along, you're able to cancel off the bottoms on a few of them as they simplify, gets rid of the fractions, and then you're able to solve through to get to your final answer. And again, just like I keep trying to point out over and over and over again, if you have that negative sign in front of that big bracket, or big bracket on top of the big fraction bar, use that and make sure that you do times that through to everything inside of the brackets, changing the sign on that second term as well.